Welcome back, ladies and gentlemen. Now we're going to go over half reaction balancing redox reaction and a half reaction method and a basic solution. So here are the 10 detailed steps. Remember, on your worksheet left-hand side, you have the shortened version of these 10 steps. These 10 steps are super similar to doing an acidic solution, with a change that occurs right here at step 6. 6, 7, and 8 are a little bit different, and then we get back into the same. So let's go through that. I'm going to go down to the example that you should have in your notes packet, which looks like this. So we're going to same thing as before, split it into half reactions. So here are our two half reactions. Te going to TeO3 2 minus, NO3 1 minus going to N2O4. We're going to balance atoms besides oxygen and hydrogen. Balance atoms besides oxygen and hydrogen. So anything but a hydrogen oxygen. Remember, we're not doing a traditional balancing here. This is a different set of steps for balancing. So I see not oxygen. We're going to look at Te. I have one Te, one Te, one N and two N, so we need to balance the N's on this side, but the TEs are good. So we're going to do that by adding a 2 right here. So if you look at the next step, I added the 2 nitrogens in front of, now I have 2 nitrogens on each side. Next step is to balance oxygen atoms with water. So I have 3, so I'm going to have to add 3 waters, and I have 6 oxygens here and 4 here, so I'm going to have to add water to balance those oxygens. I have to get those to the same. So that's what this is going to look like on the next step. I added 3 waters on this side. Now I have 1 Te, 1 Te, 3 oxygens, 3 oxygens. Over here, excuse me, I had added the 2 to have 2 NO3. I have 6 oxygens here, and I have 4 plus 2 oxygens from the water, so I have 6 oxygens on each side. Next step is to balance hydrogens with H+. I have 6 hydrogens on this half reaction, so I'm going to have to offset them with 6 H+, and I have 4 hydrogens on this side, so I'm going to offset that with 4 hydrogens. So this is what that looks like. Oops, wrong step. Let me go down one. Sorry. Here we are. This is the right step. That was a repeat step. So I have 6 hydrogens here, 6 hydrogens on this side. So 1 Te, 1 Te, 3 O's, 3 O's, 6 hydrogens, 3 times 2, 6 hydrogens. Over here, 2 N's, 2 N's, 6 oxygens, 4, 5, 6, 2 times 1. 6 oxygens, 4 hydrogens, 2 times 2, 4 hydrogens. So we're on the next one is balance the charge of electrons. So this is where we're going to go through some examples here. And we're going to get my pen activated. I will be right back in the notes when I get my pen. Okay, so we're back. I got my pen working again. So this is 0. This is 0 because 1 times 0 is 0. 3 times 0 is 0. And then this is 1 times -2. So this is -2 plus 6 times +1, which is 6. So I have a 4 here because -2 plus a 6 is 4. So I'm going to have to add 4 electrons to offset that. So I get them both to 0. Always trying to go to the smallest positive number. Here I have a -2, here I have a +4. So this side is a +2 total. Over here I have 0, and this one I have 0 because there's no charge and no charge. So that's 0, so I have a 2 and a 2. And we're going to go on and do the next piece. Okay, so what I was saying is these are 0, so this side's a 4, so I got to offset that 4 with electrons, 4 of them. And this is 2 and 0, so I got to offset this 2 with 2 electrons. All right, so let's get rid of that and go on to the next. Let me show you what that looks like. So I have 4 electrons because now I have, just going over the charge again, I have 0, 0, oops, not 0. This is -2 plus 6 plus 4 negatives. So that's a 0 charge. This all adds up to be 0 because a -2 plus a 6 plus a -4 is 6. So 6 plus a -6 is 0. So 0 on both sides. Over here we have -2, we have +4, we have 2 electrons, we have 0 and 0, 2 negative or 2 electrons here. So if you think about that, we have a total of 0 on this side because a -2 plus a 4 plus another -2 is 0. So that's what I mean by adding electrons. Okay. Next steps, this is the new step. So all those steps were the same, and now we're getting, because we're in a basic solution, we have these next 3 steps that are slightly different. We're going to add hydroxides. Remember, a hydroxide is an OH1 minus. We're going to add hydroxides to balance hydrogens on both sides of the equation, each half reaction. So both sides of this half and both sides of this half. So we are going to add because we have 6H+, we're going to add 6OH minus to this side, but we also have to add 6OH minus to that side. Over here, because we have 4H+, we're going to have 4OH minus to this side, and we're going to add 4OH minus to that side. Okay? Let me show you what that looks like. Looks like this. So here is my 6 OH minuses I had to add, and here is my 6 OH minuses. How to do it to both sides. In each half reaction I had 4 H plus, so I had a 4 OH minus, but to both sides. This next step says combine hydrogens and hydroxides. So this one and this one become 6 H2Os. And they're on that side of the arrow, so that way. And this one become 4 H2Os, and they are before the arrow, because this guy here has nobody to combine with, so he has to stay as 6 OH. Like similar on this side, the 4 OH has no H plus to combine with on that side, so it stays as a 4 OH minus. Okay, so this is what that looks like in the next step. I ended up making my 6 waters came from this 6 and this 6, and then my 4 waters came from the 4 and the 4, and then this next step says simplify waters. I'll show you on the screen and I'll show you the answer. So these 3 waters are going to make this go to a 3, and these 2 waters are going to make that go to a 2. This is what it looks like in print. I reduced or simplified my waters. Okay. So those 3 steps were the new steps that make it unique for a basic solution. Now we're going to simplify waters. I'm sorry, we did that already, I apologize. We're going to match number of electrons. So I have 4 electrons and I have 2 electrons. I need to get them both to 4. So this will stay as is. I'll multiply all of this by a 2. So that's going to be 2 times 2, 2 times 2, 2 times 2, 2 times 1, and 2 times 4. That is going to look like this. Right here. Remember, I multiplied all of this by a 2. That's how I got all those. Okay. Nothing to do on this side because we were trying to get both sides to 4 because that was the smallest number they both had in common. And then we're going to combine the half reactions. So if you recall, we're going to put this and all of this on one side of the arrow, and we're going to put this and this on the other side of the arrow. Okay, so let me go through that with you. That's what this looks like right here. This line right here is that. Now this second line is just me. I like to put both in here for my purposes, but what I would probably do if I was not teaching it to you is I probably would have done something like this, where in this top line, right, and I could have showed you this in an acid solution, I just didn't. I would say this one goes away and this becomes a 2. And then I have my 4 electrons on each side cancel. I have 4 waters and 3 waters, so that water goes away and this goes down to a 1. And then I would write what was left, because remember, if things on the same side that are identical sum, things on opposite sides that are identical reduce, so the final answer would look something like this. Thank you very much. Reach out if you have any questions.